More flavour. Okay. Good evening. Thank you very much for coming. Very impressed. We had 85 people who've shown interest in coming tonight. We are not 85 at the moment, but maybe we will be a little bit later. Either way, this has been a really good day so far. We started it off with good point, microphone. Thank you very much. That works. We started off earlier today with Subsea Day, and this is how we're going to do February events going forward. Subsea Day during the day, and then an evening gathering of like-minded people here at Littlehusa. So look forward to next year already. So just a short few words from myself. We have a few stragglers coming in here now, which is good. Maybe we will get up to 85 after all. I think first and foremost, I have to always say thank you very much to our sponsors. Without them, we would not be able to hire this place. We wouldn't be able to do the things that NOSP does. And I think we're doing a lot of good events and good activities at the moment, and getting more people involved in survey around in Norway and along the coast. So I think you have to say a big thank you to a lot of the companies that are on the screen in front of us there. I also have to say a big thank you to not moving. To the team, it's not just me and my pretty face on the front of everything. You know, I can't do it without Ricardo, who's the whiz-kiz with all the techniques, and also treasurer. We have also Alexander, who's here, is a new member of the team, and we've got Odd, who's also in the audience, but I can't see anyone because it's completely black from where I'm looking. And we've also got Armand, unfortunately he's offshore, and we hope to bring in 1 or 2 new people in the not too distant future as well. Hopefully after Easter we can put something on LinkedIn, which we're not very good with, but we should improve. Hopefully we can, when we bring that new person in, and we can get a little bit more active on LinkedIn. I think that's one of the areas that we're a little bit weaker with at the moment. But otherwise, great team, great to work together. We meet every couple of weeks and we throw lots of good ideas around. And I think this year is going to be busy. Next year, hopefully, will be another step up for us. So these are the events that you'll need to look out for this year. In barely a month's time, we're going to be in Stavanger and Goffel and Goffel. Then we'll be back here in June for another event, a break-off, and well, you can see, I don't need to list it all. And already we're starting to think about the annual dinner, which is always a good event for everyone who's there. So another full program, and next year we're looking to do things with, especially with some companies. I won't mention who they are at the moment, and we'll wait for them to come to fruition. And I think it's going to be very good for NOSP and people who are involved in that. So yeah, on to tonight's proceedings. I don't want to stand here too long. I want to hear the projects that we talked about. Main reason why we wanted to do this, and we should explain a little bit about it, was to try to get a little bit of the experience that comes from working offshore, some of the projects that we all get involved in, and try to explain and tell the students from Subsea Day a little bit about those experiences. And I think we have 3 fantastic companies with 3 good examples of what actually does happen when you finally go offshore. So I'm very much looking forward to listening to all of them. So on that note, all I will do is I will shut up, move off the stage, and bring on Emmanuel Marunga from Deep Sea. Where is he? There he is. So, and welcome everybody. Have a good evening. If you have any questions, we were going to talk about Emmanuel's going to talk for about 20 minutes. Have a few questions if there are any. Another break, and then we'll come back and have the other guys and girls on the stage. So enjoy your evening. Thank you.
Thank you so much. Good evening, everyone. I would like to start by saying thank you for the opportunity to come here and speak to all of you. I don't see you, but I know you're here. I can hear you. So, no, thank you for the opportunity to come here and speak a little bit. My name is Emmanuel Buranga. I see. Perfect. Okay. I'll just grab my water. Yeah, my name is Emmanuel Buranga. A little bit about me. I actually used to work as a math teacher for a couple of years, and I was a musician. I used to tour around Europe with the band. That was a lot of fun. We played some shows here in Berlin as well. I did my master's in business at the University in Stavanger, and now I'm with Deep Sea as an international business developer. So that's me. But I would like to ask you a question. Could you raise your hand if you ever have built IKEA equipment? Okay, good. Have you reached that stage where you some of the last stages and you let's say page 23 and you feel like something's wrong, right? Something's off, and you start flip back to page 3, and even though the screws are mounted and everything's attached, but you flip back to page 3 and you realize that this one screw you mounted the wrong way, and you can't do page 23 without having done the page 3 right. So now you're stuck with 2 options. You could force it, or you will have to disassemble everything, or at least half of what you already built. In our industry, for deep sea, this stage 3 is survey data, and page 23 is our method statement. So today I want to talk a little bit about something very simple. I'm a simple guy. I'm not a technical guy. But I will talk to you about something very simple but very expensive, the relationship between survey data and dredging. For those of you who don't know who we are a civil intervention company located in Stavanger and Kristiansund, but most of our work happens offshore. Globally, we do dredging, excavating, pile dredging, soil plug removal, rock dump removal, jetting and cutting. But what defines us is how we combine operations with engineering and simulation. And we say that offshore, when we're offshore, the most expensive place to find something wrong is offshore. So I will talk a little bit about how we will use survey data to avoid mistakes. So what do we mean when we say when survey drives dredging? We mean that ultimately the survey data determines a couple of things: what method we choose, what equipment we choose, and ultimately whether we will succeed or not. So our dredge for us is not the solution; it's more a response to the data we get. And you can imagine, for instance, driving your car, but there's this dense fog, and now you either have to slow down or you will have to take on a lot more risk, but you don't want that. And I will go through a couple of cases, very short cases. The first one is from the US. This was last year we bid on a project. They needed a diver dredge. Simple scope, 3-inch rock. We did our homework. We priced it properly and assessed the survey and bid, and we lost. So that was that. But then we asked the question, why did we lose? Why did we lose? And it turns out that they already had paired up with the diving company who told them that they had the diver dredge, what they call the diver dredge. But after a couple of weeks, maybe a couple of months, our phone rang. And hello, it's Deep Sea. Do you have that diver dredge after all? I said, well, of course. But we were curious about the specifications of the diver dredge they had used. So we asked if they could send it to us. They said, well, of course we can send it to you. So they sent it to us, and it turns out they used an impeller sewage pump. Rated for 1 to 5 semi-solids. In other words, it's what you use for wastewater or poop. So, so this is where reality meets, where theory meets reality, because in theory, technically, their diver dredge wasn't wrong, but what we like to use is, you know, this like a water mill. It has this impeller that is constantly in direct contact with the water. But we put the impeller on the outside. So I told I wouldn't be technical. This is everything technical that I will bring together. We push the water with the impeller from the outside. We call this the ejector place. And now the water has it creates a current water flow from left to right, and and this is the difference between an impeller dredge and an ejector. So this is the difference between survey and reality. Survey said 3-inch rock, but in reality, in real life offshore, there's a lot of variability. You have debris, you have hard. There's a difference between poop and 3-inch solid subsea rock. So the interesting thing here isn't that they had the wrong tool. It is that the tool they had was technically correct, but technically correct doesn't mean operationally robust. And then there was this case in Australia. This was, they wanted us to locate and recover an umbilical and for recycling. So we wanted to use our control flow excavator, which was perfect for the job. And this had a length of 50 kilometers, but with 20 survey points. And that's 1 point per 250 meters. And imagine making excavation decisions in between those points. It's very, very risky. Unfortunately, the seabed doesn't have, it's not linear, doesn't behave linearly between these survey points. So filling in the gap is not the same as actually knowing the gaps. So the problem here isn't having the wrong data. It's thinking that you have enough. Luckily, the project went fine. The client was satisfied. But this is another example of how. Yeah, there's a beautiful picture of the control flow excavator we used for that project. The third one case was from in the North Sea. Again, we bid on a dredging project somewhere between the border of UK and Norway. This time the issue wasn't not enough data. It was about the data's age. And we bid and we lost. But contractor number 1 couldn't do the job. And that couldn't contractor number 2 either. So after a while they called again. We picked up the phone, but this question was a little bit different. They asked us if we actually could tell them if the survey they had was valid. So that was a different type of question, but we said, well, yes, of course. We teamed up with some survey specialists, and they figured out that this survey was from the 1970s. And in the 1970s, I wasn't born in the 1970s, but I can imagine that they used different methods, lower resolution, lower positioning accuracy, and more importantly, the seabed has changed after 50 plus years. So the issue wasn't not enough data, but having the right data. All of these 3 examples I just gave you are very different. One of them, the first case, it's about the wrong equipment. The second one is more of the data density, and the third one here is the age of the data. Like, how many here lives in Bergen or around west of Norway? Yeah, would you Would you go on a hiking trip on the mountain? Would you plan your hiking trip tomorrow based on last week's weather forecast? You wouldn't, right? So it's the same idea here. You want the fresh and the freshest data when you work offshore. So same root cause, different symptoms on those three different cases, but same root cause. I would use the word interpretation. So what we learn from this is that whether you build your furniture from IKEA or work with 50 kilometers of Australian seabed, a little misunderstanding or the wrong assumption at an early stage, it's very critical at the later stage. And I'll just end by saying that dredging does not, for us, it doesn't start with the right equipment or it doesn't start offshore. It starts understanding the seabed. So we're very happy for good surveys. Thank you. All right. Any questions?
Okay. I have.
You have.
Yeah, just one quick one.
Yeah.
I don't know deep sea. I know that you rely heavily on surveyors, and you wouldn't be anywhere without us. So you're welcome. I'm just wondering, I don't know deep sea. I don't know that sort of market too well. How much automation and remote operations? So if you start maybe moving away from the main core of what your presentation is about, how much remote operations are you now starting to see, and maybe how is that affected by surveying as well? Is that can you explain a little bit?
Remote operations, we're not fully there, but we know it will save space on the vessel, and we know if less crew is good. But for our what do you call it, simply in the simulation rooms, we are all currently working on having more onshore operations. It's very possible, but we will always need technical people for the switch of some technical wear parts, etc. So we are working on it. Yeah.
So where do you get most of your survey knowledge from then?
Our survey knowledge.
You're concentrating on dredging, modelling, whatever you want to call it. Where does the survey side, for the students maybe who don't know that, where does that fit in? Do you contract it out? Do you have people in-house? How does that work?
We don't have people we have people in-house looking at the surveys that we get, but the surveys we get it from client every single time. The surveys comes with the scope. Most of the times, I think all the time, we ask for more data.
But if you're offshore on a vessel, are you on vessels of opportunity? Do you have your own? Do deep sea have their own vessels?
We work on our clients' vessels.
Yeah, okay.
We don't have our own vessels.
Okay.
Yes.
So you're very much relying on the survey spread that's on that vessel when you turn up with your equipment.
100%, yes.
Okay.
Yeah.
Okay. Does anyone else have any questions at all? No? Okay. I tell you what, Mike, thank you very much, everyone.
Thank you.
Okay, I think I might just change the script a little bit tonight. If who's coming on next?
Reach.
Do you guys want to do this now and then we'll take a break afterwards? I think that might be.
I just have to check something first, but it should be fine.
What do you need to check?
Just one sentence in the slide.
I think you can't hear me. I think what I should have done was really stick to the plan. I had a plan, stick to the plan. Should have stuck to the plan. Huh? He's gone to the toilet. No. Huh?
Hade du den presentationen? Ja.
Det var en fejl i en sætning der, og så skal jeg tjekke en. Hej. Okay.
Kenneth, you ready?
Yes.
Okay. All right. Okay. Let me just take a quick introduction. So, I've completely messed up the schedule now, but I think this is better. We'll have a good presentation from Reach, Subsea. Thank you very much. Trying to remember it all, and then we'll take a break, and then we'll come back and have our coffee. So I'd just like to welcome to the stage Kenneth and Felix, and yeah, thank you very much for guys coming.
Thank you. Thank you for having us. So we will split this presentation in two. I will do the reach mode part, and Felix will update you on the project that we did on the geophysical details, or give whatever we give geometric details.
Geophysical, yes.
Yeah.
That's right.
So, Felix.
All right. Well, thanks for the introduction. I'll talk you through this project here, the Scarborough gas field time-lapse gravity monitoring, reach remote down under. That's well, not fully completed, but we're getting there. The vessel you can see here is the reach remote, but I mean that part Kenneth will talk about. First, a quick introduction to the Scarborough gas field. You see a map to the top right here. We are in northwestern Australia. You can see actually there's a pointer here. We're right there. And the Scarborough gas field is located here, 375 kilometers offshore, which is relatively far. It's operated by Woodside Energy, and this is a really big new development, $12.5 billion. And yeah, just a few more numbers. This was discovered in 1979, which is actually the same year as Troll. But it was they found it's completely, I mean, dry gas, which there was very little interest in at that time. They wanted to find oil. So it's been known for a long time, but since it's so far out, Yeah, it's not been developed. It had not been developed yet. The size of the reservoir in terms of area is actually very similar to Troll, 800 square kilometers. And I mean, I'm comparing it to Troll because that's one you may have heard of if you live in Bergen. It's just offshore. There's a 110 meter dry gas column in that field, in poorly consolidated fan deposit sands with 30% or so porosity. That is only 950 meters below the seabed, which is actually quite shallow compared to lots of other fields, in 950 meter deep waters. But that's how water depth is relatively large. And there's 325 billion cubic meters of gas in place there, which is very comparable to the Ormen Lange field in the Norwegian Sea, if you know that. So that's about a third or so compared to Troll. And the project is basically, well, they have been producing gas from those fields here, but I mean, they've known of these for quite some time, and this is another 175 kilometers out. So the whole development is building 430 kilometers of pipeline to the LNG processing plant here on shore, then a floating production unit, which you see here being put in place 1.5 months ago or so, and then, well, wells and so on of that Scarborough field. Their plan is to start production later this year. They have 8 wells, and yeah, those will be feeding the pipeline and then go here, go on shore to an LNG plant that will liquefy the gas and then export it and use it for domestic market. And well, that's the LNG plant which needs to be extended and so on. So all in all, it's a very big project. And so why did we, as Reach Subsea, go there? And well, so if you look at the reservoir, and I guess the part that I forgot telling you is that I'm not a surveyor, I'm a geophysicist by background. I mean, I've been in Bergen for more than 10 years in seismology, and now I'm in gravity geophysics, basically. Well, that's relevant because when I tell you a bit more about the reservoir, I don't know how much you have been thinking about the subsurface all in all, but let's see, when they start producing gas, what happens is basically the pressure in the reservoir starts dropping, and that means that, well, the reservoir will compress a bit, and the seafloor above, no, it's empty, no, I was covering it, and the seafloor above will subside a bit. And that's exaggerated here, but I mean, this was the seabed at the start. Then after some time of production, I mean, you will notice that it's subsiding. And well, so what you want to do to understand your reservoir as good as possible, to optimize production, is you want to basically map where the pressure drops, how much, and how compressible the reservoir is, and you want to outline how good different parts of the reservoir basically communicate with one another, or whether there's faults that you didn't know about that are fully sealing the parts. And you want to improve your geomechanical model of the reservoir. So, and that's something you can find out about if you can measure exactly how much it's subsiding here. And now, I mean, we do that, and I'll tell you more about that later, but one other thing you can actually use as a method to measure what's going on out there is gravity. So, I mean, gravity, you probably have a number in your head, 9.8 meters per second squared, but that's only a bit of the truth because it can vary depending on where you are on the Earth. Because if you're closer to denser masses, those will pull you a bit stronger. I mean, it depends on the distance. And if you look over time, what happens here is gas is being produced out of the reservoir, and in this case, basically the aquifer, the water is coming into the reservoir. So much denser material, the water replaces the gas, which means that the gravitational pull in that area will be a bit higher when you measure it at the seabed. And this is relevant if you want to find out basically where your unproduced compartments are, where the gravity did not change yet, how strong the aquifer is, and how much of the production here happens basically just with the gas expanding or water coming into the reservoir. You can quantify how much hydrocarbon there is in the reservoir and then find out about the drive mechanism. And just a few more words about Scarborough. So this is a completely new development. They have drilled wells for exploration in 8 locations over an 800 square kilometer area. So you don't know too much about the subsurface in that area yet. Of course, you have other geophysical surveys like seismics, but there's still big uncertainties, especially on the natural extent of those sands. And here's a cross section to the whole area. This is the Scarborough Reservoir, and you can see it's quite shallow compared to all the other red reservoirs. I mean, there's some oil in green at shallow depth, and it's quite flat. So it's really critical to know exactly when the water starts moving towards the wells, so that they know when they need to stop producing at that well, or basically plug it, so that they're not starting to pull the water close to the well, which is that's where you lose a lot, because you can't produce any more gas. And they don't know so much about exactly how compressible the reservoir is, where water will be coming into the reservoir first, and where it will be depleting through pressure. So they have the wells to monitor it, and they also do time-lapse 4D seismics, which is extremely expensive. And then they will do one more thing, which is the time-lapse gravity and subsidence monitoring that we in Reach Subsea here in Bergen offer, which we call the G-Watch technology. I mean, offshore nothing is cheap, but it's a lot cheaper than time-lapse seismics because it doesn't require as much equipment, and you don't need any guns that you shoot. So it's a completely passive method, which is nice for the environment. Basically, the goal is to inform the reservoir models to optimize production, because it's a very expensive project. If you make a mistake in production, then suddenly you're able to produce much less gas than you wanted to. So, quick explanation of G-Watch. We have now the vessel. This is already the Reach remote vessel, which it wasn't always, which has a world-class ROV carrying this yellow sensor package, which you can see here in the actual picture from a subsea. And you have concrete pads located in a grid on the sea floor, and that ROV carries the sensor package, places it on the concrete pad, measures for 15 or 20 minutes, and then goes to the next location. And we measure 2 times at every location, basically. And here's the grid of stations at Scarborough. It's about 220 pads that we can go to. And what you can see here is actually results from the feasibility studies we did for that field, basically predicting how much substance you would see after 2 years of production at the field. So this is the seafloor deformation in centimeters, so up to 5 centimeters of subsidence, which tells you about the reservoir deformation. And then there's which of the time-lapse gravity change, which can be positive in areas basically where you expect water to come in and gravitation pull to decrease, and negative in other areas where mainly the gas is just being extracted and starts to expand, but no water comes in. And so the units here, that's 1 microgal. If you have not heard that unit, that's basically 1 times 10 to the power minus 8 meters per second squared. So we're measuring 1/10 of a billion of the gravitational, acceleration. And that equals basically to a change of 100,000 tons of mass at the reservoir depth of 950 meters, or a rise of the gas water contact of 30 centimeters. So that's what we all do this for, which I showed you in the last 2 slides. We achieve time-lapse gravity accuracies of less than 1 microgal and less than 2 millimeters in seafloor deformation measurements in consecutive surveys. And how we do that is basically the critical part is survey design, having control of the sensors, and then using basically the 0-level stations, those here, to calibrate all the data that you record in the field, to those 0-level stations, because the assumption is that basically you have no subsidence and no time-lapse gravity change at those. You have only those changes only inside the field. And just a few more words. I mean, this is, measuring this type of stuff is kind of exactly at the boundaries between surveying and geophysics. So I guess especially gravity is part of geodesy, part of geophysics. So I hope this is also particularly interesting for this group here. G-Watch has been in use a lot on the Norwegian continental shelf, and all the big gas fields here have been surveyed with it in consecutive surveys. And now, of course, a trawl has been for more than 25 years. And with the reach remote vessel, of course, we take it to the next level, that we don't need to send people out offshore anymore. Well, I mean, people can work from the office. You have less exposure to any risks out there, and we are increasing the operational efficiency with this as well. And data quality, I mean, is what we live off, because if you can't measure it this accurately, then your data is useless. But it's been looking extremely good also with the reach remote vessel. So just a quick timeline of a project like this. I mean, we start with a feasibility study, have the concrete pads built and deployed, wait for them to settle, basically, and then we start the first survey, which is happening at this time today. And in 2 years, I hope we'll do the next one to map the first time-lapse changes, and then throughout the duration of the reservoir, we'll do periodic surveys with a few years, some room in between, to basically inform the operator, which of their reservoir models are best describing reality. And we are basically the only ones that offer seafloor gravity services in the world. I mean, I guess the market is not the biggest there yet, but we are, of course, expanding internationally with this, especially with this survey. And us, that is mainly the monitoring division of Reach Subsea in Bergen that do the instrumentation and the processing. But then again, G-Watch is fully integrated, within Reach Subsea, where we can offer the whole package with vessel and ROV and survey. And vessel, that is the one you will talk more about now.
Yes. So this contract, I believe, was initiated quite many years ago, and of course the intention at that time was to use a conventional vessels, conventional ROV, and mobilize the ROV and do the work. But in the meantime, the Reach Remote came into production. We did some good trials on the first one, and it was decided even more or less on delivery that number 2 would go to Australia to do this scope of work. So that was decided. The Reach ROV, which is a big vessel there, you can see it's the small spot there on the big green one. It was lifted off on board in Horten, and it was transported down to Perth, Fremantle. But when did this happen?
In the fall.
This autumn. Yes, last autumn. And of course, we are working in a remote location or another part of the world, another country. So this vessel has been changed. It's not a Norwegian vessel anymore. As you can see there, it says Reach Remote 2, Fremantle. So it's actually an Australian vessel for the time being. We did some mobilizations in Fremantle, did all the necessary checks on the RV systems, checking that everything was still up to date after the long transit. Whilst kind of the approval process for approving the vessel for being allowed to work in Australian waters was ongoing. We kind of also did installed the rock center in Perth which includes all parties, masterly for the Norwegian safe navigation, ROV control, survey control, and also the monitoring, the Felix people. And when we did all that, we sailed from Oslo to Scarborough field for operations. And just to give you, it's not like the distance from Perth, Fremantle up to Oslo is almost as long as Norway is. So we took like 5 days for sailing distance. It's like 770 nautical miles. I think that is close to 1,200 kilometers or something. So it's quite we are talking of big distances there. And up in Oslo, I think there is one petrol station and that's it. So it's a very remote area. Perth is the million city, the biggest million city, remote million city in the world. That means the furthest away from other million cities. So Australia is big and distances are large. So we have the mobilization ports up in Offshore, which is like a 24-hour sailing out to Scarborough field. So that's about that, and then we are going into the reach remote concept. It's not the vessel itself. Of course, we have the vessel renamed Reach Remote, but it's also about the ROV, Zero, which is a new design, new concept. This is Reach Remote 2, so we have model build number 2 on board this, so it's Zero number 2. And of course, to support all the services that we need to command and control everything, we have Reach Horizon. I'm going to dive a little bit more into details about that over the next few minutes. So this is the specifications Reach Remote, 24 meters long, have a DP class 2, if it had one more extra propeller, so it's almost DP class 2. But it has the systems to do that kind of it's the DP system control system delivered by Kongsberg, and the design and everything is from Kongsberg. We do have some hull-mounted equipment as well for the survey-interested people. For this one, we have a dual AM 2040, and we have the Topaz PS 120 sub-bottom system. And the design around all this is for 30 days of operations without any maintenance. And as you could see on one of the slides, on the first swing that we did on the Scarborough field, we sailed for 26 days between port, and the ROV was diving for 18 days continuously in operation. It's not like residents laying on the seabed doing nothing. It was in operations. And I think that must be very close to the world record, if not. So that means the system that has been developed and that we're using is very capable. The Zero itself, it is a just design. The difference is very comparable to a supporter system, but the difference is the electric propulsion. In general, the sizes are very equal. And because of this new design, we are getting a much more payload capacity. So I think we are talking about very close to 500 kilos in payload on this. So it's a full-size work class ROV. It's not a small observation class, it's a full-size one. The ROV itself resides within the moon pool of the Reach Remote. So it's a cursor-based launch and recovery system with a TMS. And as you can see, in this area, we have the garage. You can see a kind of a picture from it there. This is just kind of a sketch. And here you can see the system that we are using on Scarborough field, mounted on the ROV. So we have spare parts for the sort of measuring buttons that we put on the seabed, that we put it on the side, and we have the kind of the clock itself, the side in between. The operations rock centers we are quite agnostic to how we solve this. For the time being, operating Reach Remote in Australia, we are doing follow the sun principles. So we have a full capable rock center in Perth. That means the masterly for safe navigations. We have the ROV operation personnel, we have the surveyors, and we have the monitoring guys observing the data from the gravimetric logging systems. And that is happening on the daytime in Australia. whilst in Bergen, on daytime in Bergen, we have monitor guys and surveyors. So they are taking over when the sun is going down in Australia and the sun is rising in Norway. We just swap spot. And I would say that that is what has been working quite well. Yeah. So that is the concept. We are master. We also have a masterly in Horten. You can see on the right there. We have the ROV control also at Husøy, and we also have survey control in Billingstad as well as in Bergen. But we are also now building a full complex rock system in Husøy to where we can merge all disciplines if the clients would prefer that. Because it's difficult to be a client to be on all these spots at the same time. So sometimes he would like to be at the scene where stuff is happening. So we are agnostic to that as well. This is when the ROV has put the clock on this concrete platform, and we do a measurement. And then we are putting this ROV on the seabed, and everything is dead silent. They are not allowed to talk in the rock as well. They have to be very silent because the disturbance of the equipment 100,000 kilometers away. I'm just kidding. But, yeah, so the ROV is sitting dead on the seabed, and everything is focused on getting good measurements. It's only the cameras that is kind of in operation on this. I'm just showing this video of part of the section as well because it displays the way we can replay data. I will probably come into a video presentation of this later. I'm not sure how much time I've been used, so I have more to show.
Yes.
Do we have time?
Yes.
Okay. Yes, Reach Horizon, that is our... Is everything running here? Yes. Yeah, that is the system that we are using to observe and understand what's going on board the vessel. It is our eyes and ears of what's happening, and also gives us the quality measures that we need to understand that the data that we are collecting is of good quality, and it also gives us opportunity to control systems on board while we are doing operations. So the upper video here is when this is the safe navigation part, where the navigators is looking out their windows, and on this particular video you can see it sailing up Karmsundet, for those who knows this area, and you could see it actually recognizing a lot of stuff, recognizing AIS, it's recognizing lights, warnings, everything, so it's automated into the video presentation. And you could see this is the path, the highway for the ROV, these lines on the video. This is the course from the ECDIS, showing that, okay, this is the direction we are sailing. It gives the navigator quite a lot of information. From the survey perspective, we are not so interested into the site above. Of course, it's nice to see when it looks like this, but we are more interested in the lower section here. And there we are seeing, we are merging to, oh, what happened now? Should I go away or? Okay. So. What?
Just keep it to the right. Okay. Oh, let's move this. I think that's it. Okay.
Okay. Yeah, try again. So this is kind of, this is the subsea thing, and this is what we are, as surveyors, are interested in. And we are seeing, we have the survey log, we are explaining what's happening, where are we at in the project that goes down here. We can see some, this is photogrammetry work, the buoy is working hard there. This is the conventional, this is the buoy, what we see from buoys without any, the lightning, the lights, which you can see in the conventional camera. We have the navigation packet we can see, we have the GIS presentation of where we are at, and we could see the multi-beams. Yeah, we could implement whatever we like on this, basically, and we do that. We can access this Horizon as long as we have an internet connection. It's controlled. We have to be on a virtual VPN connection, and the access is it's controlled. Yeah, I go to the next one. Just to give you some examples of what we're doing, since we have the capacity of doing hull-mounted systems, dual multi-beams in the hull, and we have the full-class ROV with the multi-beam heads, full-edge tech, side scans at bottom. We did a project for a client. He would like to have a reconnaissance survey up front to understand where we could potentially put some assets on the seabed. So we did a full coverage run with the EM 2040 resolution, typically 1 meter. The guy was working on the data because it's transported into shore immediately. The client was working on the data, detailing the route for the ROV, and then the ROV took over, following the route and giving a resolution of 10 centimeters multi-beam data with side scans at bottom at the same time. And that is brilliant. I think maybe we were talking about a little bit earlier about this, Julian, and said that was maybe done before, but it's not done too often today. But that is the capacity we have, and it's a quick turnaround. On the same project,
was an incredible smell of fish food that we had to deal with for months on end, and I tried vainly to get one gyro to be calibrated perfectly. I stepped out of the room, he took a screen dump of it, absolutely left it on the screen, I came back thinking, oh, this is it, perfect. and I, for about half an hour, I thought that our equipment was calibrated, we just good to go offshore. And then I discovered that that screen dump was there of when he took it, when it reached that perfect moment, and I thought, you wanker. And for some reason, I always remember that. It's always good working with this English, so I'm very much looking forward to your presentation. So the floor is yours.
Thank you very much, Stuart. You don't get more fun than you make yourself, I guess. So, yeah. Thanks to the committee for inviting me to have a presentation here today. Today I'm going to talk about tolerance, budget, and the impact on accuracy it has on project results. So this is our biggest development field today. Yggdrasil is located between Alvheim and Osberg in the North Sea. It's the biggest ongoing project we have in the North Sea today. Lots of reserves, close to 800 million barrels of oil equivalents. Extensive new infrastructure. We have installed quite a lot already, and we are planning to start the production in 2027. Zooming in a bit, we have the main hub in the south called Hugenay. It's also see here. Then we have an unmanned platform for the south called Hugen B. We have lots of tie-backs templates, Langfjell Nord, Langfjell South, Rinn, Funa, Peras, Fula, Østrik. A few years ago, this field was called Noaka because it was north of Alvheim and Ashla Krafla. It was kind of a joint venture with Equinor. We were planning to develop the field together with Equinor. But we couldn't agree who had the best solution for making money on the field. And the governors could never agree. So eventually we got the whole field given, or not really given, but we are the operator. Some students here today. So we have license in the field. We cannot own the field 100%. That's not allowed for the original law. We have to have shared with someone or the oil companies. It's about pitching and risk. But we have like 87% of the license in the south here. And up here we have 50% license shared with so that would be Nunin and Krafla. Nunin is a topside subsea processing platform. Talking about remote, there's been a lot of remote today. I went to see the Fugos eclipse today. It's very interesting. It's also interesting to see the presentation from you, Kenneth. And Devotion also has a USV. But that is, compared to this is the biggest remote project ever been done. Everything here is going to be remote. All the tiebacks and everything is going to be controlled from our office in Jota. We built a new office, mainly because we're going to do everything remote, offshore. We had to have a backup as a platform system as well, UPSs and all that system in place. So we have a new office. We moved in there in last autumn. The main hub is the Hugenay. Only 40 bed spaces. We do have a platform here actually. Sorry, I mean a heli deck. The other ones we don't have a heli deck. Not here, not here. Because we can do walk to walk using a boat. And transport people to the platforms that way. Maybe just only for maintenance and all the stuff, because they are all going to sit in the remote center in Stavanger. So, we were planning to install this jacket. The jacket is the foundation of the topside platform. The jacket itself is 22,000 tons. The topside is roughly between 28 and 30,000 tons. So this was a normal project support. I forgot you said Stuart, I have to tell a bit about myself, but I didn't do that. My name is Sigve Halvorsen. I work in Aker BP, as you probably understood. We do support actually quite a lot survey-wise in Aker BP. We used to only support rig moves and shallow answer site, not shallow answer site survey before. But we also now include mainly everything: subsea operations, IMR, topside measurements. And this was a typical, what I'm going to explain now is a typical project support. Where project coming asks, we're going to install this jacket, can you just make me a seabed chart? Easy peasy lemon squeezy. I've done that many times before. So I did that. Here it is. This is a jacket I just briefly mentioned. It's going to be installed. It is something gray here, but it's quite often in projects you actually mush it around a bit. The position when you are happy where it should be positioned. But the right one is where I actually ended up. And here I also included a jack-up rig, because we don't install any drilling towers on platforms anymore, because having a a jack-up rig generation 5 was proven to be 3 to 4 to 5 times more efficient actually to drill. So that's why we use that. So far so good. I sent that to the project. Here's your map, because they needed to. We did a survey, a site survey with the ocean in 2021 using the flowhawk. But then I sent this off, and then the accuracy discussion started. And why is that? I'm going to try and explain why. Over the years, we have done an analytic based on the air gaps, because we have waves. We don't want waves to hit the top of the platform. That could be a risk for people on board, and a risk for infrastructure as well. When I started in this industry, or not, 10, 15 years ago, we always talked about 100-year wave, which is around 17, 18 meters wave heights. But that wasn't good enough. Then we started to talk about 1,000-year waves. And the basis today is 10,000 meter, 10,000 year waves, not 10,000 meters, that's totally wrong. 10,000 year wave. And that's roughly around 23, 24 meters. So what they want to do, the engineers, they want to have maximum air gap. So this was designed to have 26.5 meters air gap. And then the design was of the seabed depth. So there was 190.55 centimeters. So far, so good. The problem is actually that this is on the limitation of Pioneer Spirit lifting capacity. We use this vessel quite a lot. It's like a jacking system. Put the platform there and you jack it up and put it on the top of the deck. You can also actually bring the jacket in the stern. Little side note, we use also this to remove the jacket in Ekofisk, because we have a tie in Ekofisk. And then we did the Aspen survey using this boat. I'm quite proud of that. We had 500 by 500 meter Aspen survey using that. Quite proud owning that data. I'm sure there's no one having that on the CV. There was a discussion about the why I sent them the map, and they were complaining that where they didn't like the depth we provided, and they asked about the accuracy. And then I asked them, where do you get your accuracy from? Where did you get that from? The design. And as you can see, it's based on the measurement from the drill string. And to copy Emmanuel today, that you wouldn't go to the mountain and base it on last week weather forecast. You wouldn't base the deco based on the measurement from the drill string, unless you work in Aker Solution.